Hi guys, so we are going to solve a very famous problem today. So the problem that we'll be solving is based upon dynamic programming, and an important prerequisite for that would be knowledge of fundamentals of dynamic programming. So if you feel that you are a beginner to dynamic programming, then we are going to post some links just below this video. You can just go navigate to that link, and then you will be able to learn some of the fundamental concepts of DP. Yeah. So let us hear the question first. So the question says that I have been given two strings. Okay. So the strings are S and P. Okay. Now this S basically means my input string. You can treat it as your input string. And this P you can treat it as a pattern. Okay. So there is a string and there is a pattern. This is what you should understand. Now the string S, it is composed of characters from A to Z. By that I mean any character of this string S will be something in between A to Z. Okay. So no character would be outside this. Okay. So I can have a string S that looks like A, K, L, B, M, Q, R, something like that, right? Okay. Now let's talk about P. So P is a pattern and it can be composed of any character from A to Z. Okay. So anything from A to Z is allowed as a character of pattern P. Apart from that, a character can also be this question mark, and a character can also be a star. Now let us understand what is the meaning of this question mark character. So this question mark character basically means that it can match with any one character. So basically this question mark is eligible to match against any one character. So this question mark can match against A, it can match against B, it can match against Z, anything, right? So that is the significance of question mark character. Now what is the significance of this star character? This star mark can match with any sequence of characters. Okay. So it can match with any sequence of characters. By that I mean to say that the star mark can match against a sequence like A, B, B. The star mark can match against a sequence like B, M, Q, R, S, T, anything. It can match against just P also. Yeah. And also it can match against an empty sequence. So basically it can match against any sequence of characters that also automatically includes its capability to be matched against an empty sequence, which is composed of 0 characters, right? So here I can write it, including empty sequence, right? Yeah. So now what is the real problem? So the real problem is that you have been given string S and you have been given a pattern P, and then you have to tell me whether this pattern P matches against this string S or not. Okay, let's take a very easy example. So let's say string S given to me is A, K, Q, M, and string P given to me is, let's say, A question mark star. So here if I take a look, then I can clearly say that, hey, this A and this A are matching against each other. Now since question mark can match with any one character, so I can match this question mark with this K, and since star can match with any sequence of characters, I can match this star with this entire thing, and then I can happily say that this A question mark star is being matched against A, K, Q, M, right? So this was a very simple example. So if there is a match between S and P, you are supposed to return true, saying that yes, there is a match, and if no, then you are supposed to return false. That's the demand of the question. Okay, now let's take some other inputs. So let's say I give you S, which contains A, D, C, E, B, and I give you P, which contains star A, star B. Please pause the video for a while on your own and think what should be returned here. Should I return true or should I return false? So the correct answer for this is I should return true. And let us understand why. So I can say that, hey, this B can match against this B, and this star can match against this entire thing. Okay, so this star can match against this DCE. This A and this A can match, and this star can be treated as empty. So let's say there is an empty thing over here. So this star matches with empty. So I can say that this P and S are being matched against each other. So I return true over here. Okay. Let's take another example. So let's say I have string S that contains CB and string P that contains question mark followed by A. So what about this? So again, you can pause the video for a while and wonder if I should return true or false here. So if you guessed it correctly, the answer over here is false. Now why is it false? Because if you start matching, let's say you start matching from the end, what you would find is that this A and B are not matching against each other. Now because this A and B are not matching against each other, even if you consider this question mark to get matched against this C, your work is not going to get done, right? So here it is a clear-cut false. Okay, another example. So let's say I give you string S, which is A, C, D, C, B, and string P, which is A star, C, question mark, B. So take a try at it, whether it should be true or false. So again, let's say, so guys, usually, while trying to solve for these simple test cases, you might be getting certain approaches in your mind, right? So you might be attempting to match S and P either from the beginning, which is from first character, or from the end, which is from the last character. You can choose any way of matching, right? So let's say I start matching from the end, okay? So I can say that, hey, this B matches this B, very good. This C can match against this question mark, right? Because question mark matches exactly one character. This D now cannot match this C, right? And because this D cannot match this C, even if you match this A, and if you consider this star to match against this C, or let's say you consider this star even to match against this C as well as this D, then this C is being left alone. It is not getting matched with anything, right? So in this case also you're supposed to return false. Okay. So cool. These were some of the test cases. Okay. Now what you can do is you can maybe pause the video for a while and think that how would you start matching. Okay. Yeah, so now let us understand that how can we perform that matching. So let's say I have been given a string S and I have been given a pattern P, okay? And I have to check whether both of them match against each other or not, okay? So let's say I start matching from the last characters, okay? So you can start from the first character also, you can start from the last character also, it's your choice. So let's say you start from your last character. So let's say the last character of string S is A, and this is ith character. And let's say pattern P has a last character which is also A, say for example, and this is jth character. Okay, because they need not be of equal lengths, they can be of different lengths, S and P, right? And yet match against each other, because star can match against a sequence of many different characters, right? So let's say this is the case. Okay, now let us imagine I am writing a function isMatch. This function isMatch takes two strings, let's call them string 1 and string 2, okay? Or maybe let us better call it pattern, okay? String 1 and pattern 1. Now, if it finds that string 1 and pattern 1 are both matching against each other, it would return true, otherwise it would return false, okay? This is the definition of this isMatch function, okay? Now, how do I denote this string 1 and how do I denote this pattern 1? Okay, so either you can pass the entire strings or you can do a very simple thing. Because if you take a look over here, what is happening? If you are at ith character over here and jth character over here, many different things can happen. First thing that can happen is that this jth character is a lowercase alphabet. So let's say I'm considering this case 1 where PJ is a lowercase alphabet. Okay. Now if this PJ is a lowercase alphabet where PJ is the last character of pattern P and SI is the last character of string S, okay, then in that case I can say that, hey, S and P will match if and only if this character is same as this character. This is essential because if the last characters of both the strings are different from each other in this category where PJ is an alphabet and let's say they don't match, then it's guaranteed. By guarantee I can say that no matter what you do, S and P will be different from each other. Let's imagine a case, let's say you had a B over here. If you had a B over here, this cannot match against this A, right? So you can clearly say that S and P are not matching, right? You might have some other stars preceding it, and those star or those question mark or those other characters that are preceding it might match some other characters, but this B is not going to match anything, right? So if you find that PJ is a lowercase alphabet where PJ is the last character of P and SI is the last character of S, then you can say that is match for IJ. What should it return? Now, there is an important thing that we should all understand. What is the meaning of is match IJ? So I said that I'll be passing a string. Now what I am saying is that instead of passing the two strings, I'll just be passing index I and index j. Index I denotes that I am trying to check whether my string S, which is from 0 to I, matches against my pattern P, which is from 0 to j. This is the physical significance of this thing. Okay, so if my string S from 0 to I is matching against pattern P from 0 to j, then this thing is going to return true. Otherwise, this thing is going to return false, right? So that's what the definition is of is match IJ, right? Now, if this is the way I am defining my is match IJ, so in order to try to match string S and string P, you would pass the length of string S, you would pass the length of string P, okay? Because only if you pass the length of string S, not exactly the length, but length minus 1, which is the last index, and the last index of string P, then only you can say that, hey, based on this definition, you're attempting to match the entire string S with the entire pattern P, right? Yeah, so let us understand what are the cases that are going to be over here. So in this case, when PJ is a lowercase alphabet, then I can say that, hey, this thing will have a response which is equals to PJ equals to SI. Why I'm writing this is a Boolean expression. So the moment this thing comes out to be false, then this entire thing would be false, right? But if this is true, if let's say the last characters are matching, then is that sufficient enough to say that, hey, this entire string S and entire pattern P are matching to each other? No. Because now what should happen is that this much of string S and this much of pattern P should be matching against each other. So now this is the step where I have broken down my large problem into smaller problems. What was my large problem? My large problem was an attempt to match the entire string S and entire pattern P, okay? But here, what I am doing is, if I see that these both are matching against each other, in that case, all that I need to do is, I need to check if this much is matching against this much or not, okay? So, this is one condition that is needed, and another thing that should be true is that is match of I minus 1, comma j minus 1 should return me true. So, only if both of these are true, then this thing would be true, okay? Otherwise, this thing would be false, right? So, this is the case when there is an alphabetical character at P of j, okay? Now, let us consider other cases. So, what can be possibly other kind of characters at P of j? So, I can either have a question mark. So, let's say else if Pj is equals to question mark. So if pj is equals to question mark, so I had a string s that was ending with a, and I now have a string p which is ending with a question mark, right? Then I can say for surety that, hey, since this can match against any one character, okay, and I'm basically trying to match whether S and P match against each other or not. So I would say that, hey, this thing is exactly equals to A, and I will let it match with this. Now, the moment you let it match with this, your job for the last characters of the two strings is done. Now, all that you would want to check is that whether this much of string S and this much of pattern P are matching against each other or not. So in this case, you can say that is match ij will be same as is match I minus 1 j minus 1, right? Yeah. So again, you have been able to see that I have reduced a problem of larger size, because the larger the value of I and j, larger the strings would be, right? And smaller they are, smaller the strings could be, right? Okay, now let us consider the final case. What is the final case? So final case can be that this was my string S, which was matching, which was, let's say, ending with character A, and this was my string P, which was, let's say, ending at star, okay? Now, let's say I have a star over here and I have an A over here. What are the total possibilities that exist? As I said, star can match against any sequence of characters. It can be a empty sequence, it can be a sequence of one character, 2, 3, 4, many, right? So I can either consider its contribution as nil. By nil, I mean to say that, hey, this is signifying an empty character. So when it is signifying an empty character, then my attempt would be to match this much of S with the remaining P, right? So this is the first case where I considered its contribution as an empty sequence, okay? Another case can be, I can consider it as something which is a sequence of size 1. So when I do that, then I would allow this star to match this A. And when I allow this star to match this A, then I would be interested in checking whether this much of pattern is same as this much of string or not, right? Another case that can exist is that I can allow this star to match two characters from the end. Then I would need to know whether this much of string S is matching with this much of pattern P or not. And so on and on. There are many different sizes of subsequences that I can allow to match against this star. So I can allow this entire thing also to get matched against this. And now I would want to know whether the remaining part of string S, which is empty, whether that empty thing is same as this pattern P or not, right? So if you try to understand it mathematically, what would you write? So you would say that, hey, in this case, is match of ij, how am I going to write that? So as I said, if pj is a star, okay, then the first case that can happen is I do not consider its contribution at all. That is, I consider it as an empty sequence. When I consider it as an empty sequence, then I would want to know whether this entire string S, okay, which is till index I, is matching with pattern P, which is till j minus 1 or not, right? But there can be other case also. The other case can be, if I allow this to match against exactly one character from the end, then I would want to know whether is match. So now, because this star has been used to match this, so the portion of string S that I have is till I minus 1, whether this thing, S from 0 to I minus 1, whether it is equal to P from 0 to j minus 1 or not. Next case can be where I allow this star to match two characters from the end. If I do that, then I would need to know whether, because the two characters have been matched, so only from index 0 to index I minus 2 are remaining, and I would need to check whether they are same as the pattern from 0 to j minus 1 or not. And it would go on and on and on. And finally, I would have, the final case would be where I allow this thing to match the entire thing. So when I say entire thing, what I mean by that is I allow this star to be able to match this entire string S, which is from index 0 till here. So when I do that, when I allow it to match the string S from 0 till the end, then the remaining string S is empty. Okay, so in that case, this index would be -1, right? Okay, and then you would decrement it by 1 unit, which is j-1. Now, if any of them return you true, then you would want to return a true here, right? Because these are your elements of choice, okay? And whenever such a kind of situation happens, whenever you have elements of choice, what do? You use recursion. So, because this is your main problem, these are your states, okay? I and j are your states, and now this solution is dependent upon this, all of them. So if any of them is returning the answer that is, let's say, true, if any of them is returning the answer true, then this thing would be true, okay? And if all of them are returning false, then it would be false. So how do I club them up? So there are multiple Boolean values, and you want that only if all of them are true, then the answer should be true, otherwise it should be false. So guess what it should be? You can pause the video for a while. So I believe you might have guessed it well. So it has to be an OR condition, okay? So you can have OR, okay? So there are many OR conditions that are out there, and all of them will be ORed, and then you will get this particular value, okay? If you take a look over here in a really close manner, then you would realize one thing, that you can simplify this thing, okay? You can simplify this thing in a very easy manner. And let us understand how do I do that. So guys, what I can say is, let's say this was my string S, drawing it again, ending at A, and string P, ending at, let's say, star. Okay. Now, what I can say is that either the contribution of this would be empty, okay, which is it signifies an empty sequence, or its contribution would be non-empty. Okay. Now, if you talk about this is the call that I am making to this isMatch function when I am considering its contribution to be empty. Because I am considering its contribution to be empty, that's why I am reducing j, but I am keeping I wherever it is. Okay, and then I am attempting to match this much of string S with this much of pattern P, right? Now what I can do is that, hey, the moment I am willing to consider the contribution of this star as empty sequence, then I must decrement my j by 1 unit, because if its contribution is empty, then what is the use of just keeping your j over here? There is no use in that, right? So when the contribution is empty, then you can make a call. I'm just going to write the state. You can make a call for the state which is I, comma j minus 1. So we'll call isMatch of I, comma j minus 1. But when you consider it to be a non-empty sequence, when you consider it like that, in that case, what would you do? So in that case, first thing that you're supposed to do is, because this is non-empty, okay, so this must match at least one character, okay, so at least one character is being matched. In that case, I will decrement this I by 1 unit. But now tell me, should I also decrement my j by 1 unit? The answer is no. Because if you decrement your j as well by 1 unit, then the problem that would happen would be that you would never be able to consider cases like this, and everything below it. So because if you're decrementing j by 1 unit, that means that, hey, you just have made two choices, where the first choice is to consider it as if it is implying a empty sequence. And if you do this, then this would be just like the consideration where you are implying this thing to match against a single character, right? So instead what you can do is that you can make a call for I minus 1 comma j, right? And you can call isMatch for this. And why I'm doing this thing is because if I decrement my I but do not decrement my j, then next time, by that I mean whenever this particular call is made, then I'll again have an opportunity to consider the same character once more. Okay, so let us try to understand it in this manner. So if you write is match of I comma j as is match of I comma j minus 1 or is match of I minus 1 j, right? So here you see you are still at that star. Here you have moved out of the star, okay, because you consider it as empty sequence, right? So now if you talk about this thing, how would this be written as? So now if I try to write for is match of I minus 1 j, so you will use the same recurrence relation, right? If you use the same recurrence relation, what is going to happen is you will call is match of, so see I and I remain same here, so it will be I minus 1 over here, okay, and j got decremented by 1 unit, so the j will get decremented by 1 unit here also, okay, and about or, so in this case what happened, your I got decremented by 1 unit and j remained as it is, so here your I will get decremented by 1 unit and your j will remain as it is. Now you can plug this entire thing over here, and you can do that because this thing would be broken down in this form. If you do that, then you will realize that now you have is match I j minus 1 and you have is match I minus 1 j minus 1 also. So basically you have this as well as this, right? And now from this you will be able to generate this thing and then everything else also. Okay, so what you can do is that you can now see that how this expression is going to be broken down. Okay, and if you plug those values over here, you would actually see that all these things, all these different expressions would be getting considered if you are just sticking to this thing. So what is the rule? So whenever I see that there is a star over here, then what are the things that I can do? First thing that I can do is I can consider its contribution as empty. The moment I consider its contribution as empty, in that case, I'll just move my j and keep I as it is. If I consider its contribution as non-empty, then that non-empty means many different things. It could either mean 1 character, 2 character, 3 character, all characters, anything, right? So in that case, I'll just move my I, but keep my j as it is, so that when this particular call is made, then that j, that star can get reconsidered for another subsequent series of characters, right? So this is the overall logic, right? Now you see, now how does it look like? So whenever you see that there is a problem where there are these elements of choice, so here also you have, whenever there is a star, you have choice, right? So either your answer depends upon this or your answer depends upon this. So whenever there are elements of choice, you use recursion. So I can easily write a recursive code and have my job done for this thing. Okay, now that recursive code will just have index I, which will denote my string s from 0 to I, and index j, which will denote my pattern p from 0 to index j, and then it will do its job, which would be based on the conditions, whether the last character of pattern p was an alphabet or not. If it was alphabet, was that matching with string I or not? Next case can be, if it was a question mark, then I can directly match it against this, and then I depend upon I minus 1, j minus 1, right? And if it is a star, then I have these elements of choice. First choice is, when I consider empty contribution, then my I remains same, j changes. And when I am willing to consider non-empty contributions, then my I decrements by 1 unit, but j remains wherever it is, right? So basically you can go ahead and write the recursive code after having learned this thing. Just keep one thing in your mind, that whenever you are writing the recursive code, these are your simple recurrence relations. But another important part of recursive code is termination condition. So can you make out the termination condition on your own? Just think, what would it be? Okay, so take pause for maybe 2-3 minutes, as long as it takes, and think if you write the recursive code, how would it look like and what would the termination condition be. Okay. Yeah. So if you would have seen here, just try to understand what is happening. Like, say for example, this was the case. In this case, my is match ij was equals to, so first thing was that the last character should be matching, which is si and pj must be exactly equal. And second thing was that the portion from 0 to I minus 1 in s should be able to match against the portion in P from 0 to j minus 1, right? So you can see here that this function is dependent upon I minus 1 j minus 1. In this case also, this function is dependent upon I minus 1 j minus 1. In star case, it is dependent upon I j minus 1 or I minus 1 j. So whenever a function f of ij is calling itself again in a recursive fashion, let's say it is calling for I dash and j dash, then that I dash and j dash, no matter what kind of case you consider, those I dash and j dash are either the same, like here I is the same, or they are reducing, right? It never so is happening that you are calling for I plus 1 or j plus 1 or j plus 2 or I plus 2. You're never doing that. So your both variables which represent your state are running in negative direction. Okay, so what would eventually happen? So eventually you would see that your I might become minus 1. Similarly, your j also might become minus 1. Okay, now you have to understand what is the physical significance of I becoming minus 1. So try to understand that. So if I becomes minus 1, then I basically is a representative of string s. Okay, so from I, one can make it that the portion of the string s that I am interested is from 0 to I, right? But if I is minus 1, then it means that the portion of s that I am interested in is empty. It's totally empty, right? So basically it would say that, hey, you are trying to see if an empty string, okay, so now this is empty. If I is minus 1, then this is empty. So now you are trying to check whether an empty s can match against a pattern P or not. So can you think which kind of pattern can match an empty string? So only two kinds of pattern can match an empty string. First, the pattern itself is empty, or this pattern just has star, 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 right? Because I can treat each star as an empty sequence, and empty, 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 empty is just empty, right? So if my P1 contains all stars, or my P1 itself is also minus 1, then I can say that whenever I is minus 1, I am supposed to return true, right? Because I minus 1 means S1 is empty, then P1 also has to be empty, and for P1 to be empty, either my J has to be minus 1, which would imply that P1 is empty, or the portion of the P1 from 0 to J should be all star, 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 right? These are the requirements, okay? Now take the another case. So let's say when my J was minus 1. So when my J was minus 1, again two cases can happen with I. If my J was minus 1 and I is also minus 1, I already said that I would return true, because empty and empty would match against each other. But if my J is minus 1, and let's say if J is minus 1, that means it is empty, pattern is empty. And let's say I is not minus 1. So if I is not minus 1, that means you are talking about a string S which is composed of lowercase alphabets and it is not empty. So any string which is not empty, composed of lowercase alphabets, can never be matched against an empty pattern, right? So whenever your J is minus 1, and in this case if you see that your I is not minus 1, then you should directly return false. Okay, so these are the termination conditions that would come into picture. Okay, so let us understand how do I simply write the recursive code for this thing. Okay, So let's say I write that function is matching, and this is matching function takes I and j, okay, and it is a Boolean returning function, okay. So what do you first write in your recursive code? You should always write your termination condition first, right? So your termination condition comes if your I is -1. So if your I is -1, that means your string s is empty. If your string s is empty, it can match this pattern only if this pattern p is also empty or this is all star star star, right? So let me handle this case where pattern p contains all star star star. Okay, so for that what I would do is I would iterate on pattern p from 0 to index j. Okay, so I would iterate using an integer k which would vary from 0 to index j, and if it sees that pk is not equals to star, so tell me what should I return here. If pk is not equals to star, that means the portion from 0 till index j in p1 is not star 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 star. So that clearly means that what should I do over here? I should return false. Okay, so if this is the case, I would directly return false. Okay, and now let's take the case when this loop was over. Now when this loop is over, because you did not return false anywhere, that means this p1 was surely star 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 from index 0 till index j, and if that is the case, then you should happily return true. And now that you have taken into consideration the case where p1 would be star star star, you have automatically taken into the consideration this case also where p1 would be empty. That is the case where j is -1, because here your k is starting from 0, right? So let's say your I and j both were -1. In that case, you would have come in this loop because I is -1, and now this loop would not run because j is -1, so your k, this loop would not run, right? And now you directly return true over here. So this is one termination condition corresponding to string s being empty that has been already handled. Now another termination condition can be when my j is -1. So when my j is -1, what does it mean? It means that my pattern is empty. Now an empty pattern can only match an empty string and nothing else. So what I'll do is I'll return I equals to -1. So this basically means that only if both the strings and pattern are empty, okay, then you should return true in this case. Otherwise that should be false. Okay, now my termination condition is done. So this was my termination condition. Now I will write my recurrence relations. Okay, so which is what we have been talking about from the beginning, right? So how will they look like? Let us understand. So first case is where my p of j is star. So if the last character of pattern that I am considering is a star, then star can either be considered as empty or non-empty, right? So if you consider it as empty, then the state is ij -1. So basically you do not take into account that any character of string s from I till back is not getting matched with p of j. So you would keep your I as it is and you would just change your j, right? So you would call is matching I comma j -1. And the second case is where you would consider its contribution to be non-empty. Where you consider its contribution to be non-empty, then you change your I by I -1, that is letting go of one character and letting it match against one occurrence of that star, but you would keep your j as it is so that it can match subsequent other characters also. So you would write is matching I -1 j, and if any of them is true, then you want to return true, so you take an OR of these two values, and then this is what you would return, right? Okay. What is the next case? The next case is where your p of j is equals to question mark. So where your p of j is equals to question mark, as I said, you can allow your last character of string s to get matched against the last character of pattern p. And now all that you would be interested to know is whether the part of string from 0 to I -1 is same as the pattern P from 0 to j minus 1. Okay, so in this case you would return is matching I minus 1 comma j minus 1. Alright, and now comes the final case. So the final case is if your P of j is neither a star nor it is a question mark. What does that mean? That means it is an alphabet. Now if it is an alphabet, then two things have to be true. First thing, that the last characters of both the string as well as pattern should match, and the remaining string, which is from 0 to I minus 1, should get matched against the remaining pattern, which is from 0 to j minus 1. So in the final case, I would simply return si equals to pj, and I would make a call for is matching I minus 1 j minus 1. That's it. This is the code for this. Okay. Now let's think of one thing over here. Can I somehow improve my code over here? So basically in my termination condition, when my I is equals to minus 1, I have to iterate from k equals to 0 to k till j to see whether all are star 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 or not. And you will have to do it in every recursive call. Now doing it in every recursive call is going to be very, very expensive, right? Which you would not want to do. So what you can do is something which is as simple as this. So whenever your I becomes minus 1, it implies that string s is empty. So if, let's say this was your pattern P, which looked like this. Okay. If you figure out the index of the first character, I think here it is 3. If you figure out the index of the first character in pattern P, let me write it idx. Okay, if you figure out this first index where a star is not present, then your job would become very easy, right? Because now you can say that whenever this thing happens that you see that I is equals to minus 1, now if let's say your j was any value which was smaller than idx. So if your j was smaller than idx, what would it mean? It would mean that, hey, you are considering a prefix of p which is all star star star. So you can directly return a true over there, right? So this is very easy to do, right? You can write a very simple program to find out the first index in pattern P, okay, where there is no star. And you can store that index globally, or you can pass it by reference or by value. It is an integer, so it doesn't matter a lot. So you can do that, right? And now your job becomes very easy. So now all that you would do is, whenever this situation happens, then you would return true. As I said, you would return true if and only if your j is smaller than idx. Okay, that's it, right? So while finding idx, what you can do is that you can initialize your idx to minus 1, and then you can iterate from index 0 till the end, and the moment you see that you hit a character of pattern P which is not a star, you would change that idx to that particular index position, right? So this is what you can do, and this is how the code would look, very, very simplified. Okay, now this is a recursive code. Now you can clearly see that there are many function calls that are going to happen over here. For example, I can see that let's say there was a call for I comma j. Now if I consider this case, let's say there was a star at j, okay, then it would call for ij minus 1, and it would also call for I minus 1j. Now let's say there was a star over here also, okay, then it would again call for ij minus 2, and it would call for I minus 1, j minus 1. And let's say there was a star over here, so it would call for I minus 1 and then j minus 1. And now you can clearly see that this problem is present over here also, right? And because this problem is present at both these function calls, it means that you are trying to solve a problem over and over again. So whenever you try to solve a problem over and over again, there will be a lot more repetitions, and it would be, if you draw this tree, there would be exponential number of function calls that would be made, right? So whenever such a kind of thing happens, what do? You try to memoize it. And this is where memoization would come in handy. So memoization is again a fundamental concept of dynamic programming. If you do not know what it is, learn the fundamentals. You can watch that video, and that can help you understand what does memoization really mean. So memoization means that, hey, if you have solved this problem, then store its solution somewhere, so that next time if this function is called, then you do not solve it again, rather you return it. Okay. So how do you perform memoization? So you perform memoization by first figuring out that how to denote a particular problem. Now here, my problem is being denoted by I, j, because I represents a portion of string S and j represents a portion of pattern P, right? So I can have a memoization array, and this memoization array should have two dimensions. So first dimension will denote I and second dimension will denote j, right? And this memoization array can initially be initialized to any garbage kind of value. Okay. Once you initialize it to any kind of garbage value, then what you can do is that whenever a call is made, then you can first check. You can first check whether mem of ij is garbage or not. If mem of ij is garbage, then all that you have to do is you have to solve it and store its solution in mem of ij. Okay. And if it is not garbage, that means it was solved earlier. If it was solved earlier, then you should simply return it. That's all the logic that lies in memoization. So what I'm going to do is that I'm not going to write this memoization code for you. If you know memoization, memoize it on your own. And if you do not know, learn it and try to memoize. And then maybe I'll try to build the next video where I'll show you the memoization based code for it. Okay. And apart from memoization based code, I would also show a bottom top approach for solving this. So basically this is recursion plus memoization. If you memoize this code is basically recursion plus memoization. And whenever you have recursion plus memoization, this is equivalent to top bottom DP. This is top bottom DP. Now there is another kind of approach to solve DP problems, that is bottom top approach. In that we don't perform recursion, we simply perform iterations by using nested for loops. Okay, so I'll talk about that in the next class. So that's it. Cool.